Hello, and welcome to PsyBox. Today we are going to explore the secrets of the world's most mysterious continent. In this video, we will first present the hypothesis of a civilization hidden beneath the Antarctic ice. Second, we will analyze the science that could make this world possible. Third, we will imagine the biology and senses of its inhabitants. Fourth, we will construct a vision of their technology and culture. Fifth, we will investigate the clues they may have left behind. And finally, we will discuss what their existence would mean for us all. What if a civilization exists beneath Antarctica? Antarctica. The name itself conjures images of an almost alien world, a vast, silent continent of white, a desolate expanse of ice and rock at the bottom of our planet. It is the coldest, driest, and highest continent on Earth, a place of brutal, unrelenting extremes. In our collective imagination, it is the last empty space on the map, a pristine wilderness inhabited only by colonies of penguins, a handful of hardy scientists huddled in their research stations, and the ghosts of heroic explorers. It is the end of the world, a beautiful but fundamentally dead place. This is the Antarctica we think we know. This image of a static, frozen wasteland has made it a fertile ground for modern myths and conspiracy theories. For decades, stories have circulated in the darker corners of the internet about secret Nazi bases hidden in the ice, of vast, warm Earth openings leading to a hollow world, of Admiral Byrd's alleged flight into a hidden land of mammoths and strange flying machines. These are compelling, entertaining stories, the modern equivalent of the "here be dragons" that once populated our ancient maps. But like those ancient maps, they are a distraction. They are a work of fiction that, while exciting, obscures a truth that is far more profound, far more scientifically grounded, and ultimately far more mysterious than any tale of secret bases or lost worlds. The real secret of Antarctica is not what might be hiding in a few man-made tunnels. The real secret is that the entire continent of Antarctica is a mask, a 4-kilometer thick veil of ice hiding another, older, and completely unknown world beneath it. This is not speculation. This is a known scientific fact, a discovery that has, over the last few decades, completely revolutionized our understanding of the White Continent. For most of the 20th century, we assumed that the ice sheet, which in places is nearly 3 miles thick, was frozen solid to the bedrock below. But as we developed new technologies to peer through this immense shield of ice, we began to see the impossible. Using ice-penetrating radar, seismic surveys, and satellite measurements of the subtle gravitational and magnetic variations in the crust, scientists began to map the continent beneath the ice. And what they found was not a flat, uniform plain. They found a true continent with vast mountain ranges the size of the European Alps, like the Gamburtsev subglacial mountains, and deep, winding canyons. And most startlingly of all, they found water, not just frozen water. They found hundreds of pockets of liquid water, a vast, interconnected network of over 400 subglacial lakes, rivers, and streams, all hidden and flowing miles beneath the ice. These are not small meltwater ponds. They are colossal bodies of water, kept liquid by a delicate balance between the insulating power of the ice sheet above, the immense pressure of that ice, which lowers the water's freezing point, and the slow, steady trickle of geothermal heat from the Earth's crust below. We are not living on a planet with 7 continents. We are living on a planet with 8, and the 8th one, the true Antarctica, is a continent of dark, liquid water, and we have only just discovered that it exists. The crown jewel of this hidden world is Lake Vostok. Discovered in the 1970s by Russian scientists using seismic soundings, its sheer scale is difficult to comprehend. It is one of the largest lakes on the entire planet. At 250 kilometers long and 50 kilometers wide, it is roughly the size of Lake Ontario, one of North America's Great Lakes. Its deepest points are estimated to be nearly a kilometer deep, and all of this entire freshwater sea, is buried beneath 4 kilometers or nearly 2.5 miles of solid, ancient ice. But the most profound and mind-bending fact about Lake Vostok is its isolation. Based on the analysis of the ice cores drilled just above its surface, scientists believe that the lake has been completely sealed off from the surface world, from the air, from the sun, from any form of life from our own biosphere, for at least 15 million years. For 15 million years, it has been a pristine, untouched, and completely separate world. To put that in perspective, our own species, Homo sapiens, is only 300 years old. Our earliest hominid ancestors had not yet even begun to walk upright when the ice of Antarctica sealed Lake Vostok away from the rest of the planet. It is a planetary-scale time capsule. It is a perfect, isolated evolutionary experiment that has been running, uninterrupted, since long before our own story began. For decades, the great question was whether this ancient, hidden world was sterile or alive. The conditions are extreme: total darkness, immense pressure, and a temperature that hovers around a chilling -3 degrees Celsius, kept liquid only by the pressure. But in 2012, a Russian team finally succeeded in drilling through the 4 kilometers of ice and piercing the surface of the lake. And in the samples of freshly frozen lake water they retrieved, they found life. It was microbial life, but it was diverse, and most importantly, much of its DNA did not match any known species on Earth. Subsequent drilling into smaller, more accessible subglacial lakes, like Lake Whillans, by American and British teams confirmed it. Antarctica's hidden, watery continent is not a dead world. It is a living biosphere. This is the foundation of our entire investigation. We have now established the existence of a vast, ancient, and habitable environment, completely isolated from our own for 15 million years. An environment with liquid water, with a geothermal energy source, and with a proven, living biosphere. The scientific question, therefore, is no longer, is there life beneath the ice? The scientific question is now, what is the ultimate evolutionary potential of that life? And this leads us to the great speculative leap. What if, in the unique, stable, and completely alien environment of a place like Lake Vostok, life did not remain merely microbial? What if, over 15 million years of completely independent and uninterrupted evolution, it followed its own path? What if it became complex? What if it became macroscopic? And what if, in the eternal, silent darkness of that hidden sea, it became intelligent? This is the core hypothesis we are here to explore, that the true story of Antarctica is not about ice and penguins, but about a lost world and a hidden civilization, and that our current scientific missions to drill into these lakes are not just acts of exploration, but are potentially the first steps towards the most profound and unsettling contact event in human history. This stunning revelation that a vast, ancient and living world is hidden beneath the Antarctic ice is the scientific foundation of our hypothesis, but its implications stretch far beyond the borders of our own planet. It forces us to reconsider the very framework we use to search for life in the universe. For decades, our search has been defined by the Fermi paradox, the profound and unsettling silence from the stars, a silence that exists in stark contradiction to the statistical likelihood that the universe should be teeming with life. We have asked, where is everybody? This discovery on our own planet offers a chilling and elegant potential answer. Our entire search for extraterrestrial intelligence has been crippled by a profound and unexamined assumption, a surface bias. We have been searching for our own reflection. Our telescopes hunt for Earth-like planets in the habitable zone, a narrow, temperate band around a star where liquid water can exist on a planet's surface. Our radio dishes listen for signals from civilizations that we assume will live on such a surface, in a thin atmosphere, under the light of a Sunday. We have been searching for other surface dwellers because we are surface dwellers. But what if the surface is not the rule, but the exception? What if the surfaces of planets are the most dangerous and unstable places for life to evolve? A planetary surface is exposed to the constant violence of the cosmos. It is battered by sterilizing solar flares, bombarded by asteroids and comets, and subjected to the wild, chaotic swings of a global climate. Subsurface oceans, by contrast, whether under the ice of Earth or the moons of Jupiter and Saturn, are the safest and most stable environments imaginable. They are perfect, long-term incubators, shielded from the chaos above. The discovery of a living world under 4 kilometers of ice on our own planet suggests that the most common habitats for life in the universe may not be the sunlit surfaces, but the dark, hidden, geothermally heated oceans of icy worlds. This leads to a new and powerful solution to the Fermi paradox. Perhaps the great barrier to a civilization colonizing the galaxy is not a great filter that inevitably destroys them, but a great wall of rock or ice that contains them. Imagine a civilization born and evolved in a subglacial lake like Vostok. Their entire universe would be their lake. Their sky would be a solid, impenetrable, and continent-sized ceiling of ice. The concept of a surface, of an atmosphere, of stars, would be a piece of abstract theoretical physics if they could even conceive of it at all. The technological challenge of tunneling upwards through 4 kilometers of solid, moving ice would be orders of magnitude greater than our own space race. Their entire technological and philosophical trajectory would be, by necessity, inward-facing, not outward. Their great journey of exploration would be to map the other subglacial lakes in their hidden network, not to reach for the stars. In this view, the silence of the cosmos is not the silence of a graveyard. It is the silence of countless deep, warm, and stable homes, populated by civilizations that have no ability, and perhaps no desire, to shout into the cold, empty void of space. The universe might be teeming with intelligent life, but it is a silent, hidden majority, living out their long histories in the dark, comfortable safety of their own hidden worlds. We, the noisy, fragile, and exposed surface dwellers, might be the true cosmic oddity. This, then, is the grand, audacious hypothesis we will investigate in this journey. We will proceed with the assumption that our planet may have hosted 2 separate, intelligent lineages, the children of the sun and the children of the ice. To build our case, we will embark on a structured investigation, a deep dive in 5 more parts. First, we will explore the hard science of this hidden world. We will investigate the geothermal engine that powers it, the bizarre chemistry of a world without a sun, and the types of life that could thrive under the crushing weight of an entire continent. Then, we will speculate on the biology of its inhabitants, imagining the strange and wonderful creatures that could have evolved over 15 million years of perfect isolation in a world of eternal darkness and immense pressure. From there, we will become architects of the impossible and construct a detailed, plausible vision of their civilization, their technology, their senses, their culture, their entire reality shaped by their icy sky. After that, we will become detectives. We will ask what ghostly traces, what improbable anomalies in the ice above and the rock below such a world might have left behind for us to find. And finally, having journeyed through the science, the speculation, and the search, we will ask the most important question of all. What is our responsibility to a world we have only just discovered? And what does its existence tell us about ourselves, the loud and chaotic tenants on the surface? This is not just a story about a civilization that might live under the ice. It is a story about the ice itself, a story about the profound limits of what we think we know about the planet we call home. The greatest alien world we may ever discover may not be millions of light years away. It may be right here, in a place we once dismissed as a frozen wasteland, a silent, sleeping giant upon whose back we unknowingly live our loud and chaotic lives. To ask if a civilization can exist beneath the ice of Antarctica is to ask a series of more fundamental scientific questions. Is there a stable, long-term source of energy? Is there liquid water? Are the necessary chemical ingredients for life present? And are there plausible evolutionary pressures that could lead from simple microbes to complex, intelligent beings? The grand, speculative hypothesis we presented in our introduction rests entirely on the answers to these questions. We must now leave the realm of the grand what if and enter the world of the specific how, to build, piece by piece, the scientific case for a world hidden beneath the ice. The first and most fundamental requirement for such a world is a source of energy. Life is a process that fights against entropy, and that fight requires a constant input of energy. On the surface of our planet, that energy comes from the sun. In a world buried beneath 4 kilometers of solid ice, the sun is a distant, irrelevant myth. The energy must come from below. It must come from the planet itself. The engine of a subglacial world would be the faint but relentless geothermal heat that flows from the Earth's core and mantle. This geothermal heat flux is a global phenomenon. Our planet is a slowly cooling ember from the fires of its formation 4.6 billion years ago. Its core is a sphere of solid iron as hot as the surface of the sun, and it is surrounded by a vast ocean of molten rock. The heat from this deep furnace constantly radiates outwards, slowly making its way through thousands of kilometers of mantle and crust to the surface. The flow is weak. On average, the amount of heat reaching a square meter of the surface is thousands of times less than the energy it receives from the sun. But in a world without a sun, this faint, planetary warmth is everything. Crucially, this heat flow is not uniform. There are regions where the Earth's crust is thinner, or where there is more volcanic activity, and in these places, the geothermal heat flow is much higher. For a long time, Antarctica was assumed to be a placid, tectonically dead continent with a very low heat flow. But as our methods for mapping the hidden world beneath the ice have become more sophisticated, this picture has changed dramatically. Using ice-penetrating radar and seismic surveys, scientists have discovered that the bedrock of Antarctica is a dynamic and complex continent. It is home to the Gamburtsev subglacial mountains, a colossal, ancient mountain range the size of the European Alps, completely buried beneath the East Antarctic ice sheet. The existence of such a range suggests a complex geological history, and mountain ranges are often areas of thinner crust and higher geothermal activity. Even more exciting has been the discovery of active, or at least very recently active, volcanism under the ice. In West Antarctica, a region known as the Marie Birdland Dome, scientists have identified a massive volcanic province, with some surveys suggesting there could be over 130 volcanoes hidden beneath the ice, one of which may be the largest in the world. Deep ice cores drilled in this region have revealed layers of volcanic tephra, or ash, a clear sign of past eruptions, and satellite data has observed the ice surface rising and falling in ways that suggest the movement of magma deep below. This is not a dead continent. It is a geologically active one, with powerful, concentrated heat sources that are constantly melting the base of the ice sheet from below. This is the engine of the hidden world. It is the fire that warms the cradle under the ice. This geothermal heat is the first key ingredient that makes the existence of the subglacial lakes possible, but it is not the only one. For a lake to exist at the bottom of a glacier, two other conditions must be met. The first is insulation. The multi-kilometer thick ice sheet that covers the continent is one of the most perfect thermal blankets in nature. It traps the faint geothermal heat, preventing it from escaping into the frigid Antarctic air above. The second factor is pressure. The colossal weight of the ice, 4 kilometers thick in places like the Vostok Station, creates an almost unimaginable pressure at the bedrock. This immense pressure alters the fundamental physics of water, lowering its freezing point. At the base of the Vostok ice sheet, water can remain liquid at a temperature of -3 degrees Celsius. The combination of these three factors, geothermal heat from below, perfect insulation from above, and immense pressure lowering the freezing point, is what allows for the existence of a vast, continent-spanning network of liquid water. And the scale of this hidden, watery world is staggering. We are not talking about a few isolated meltwater ponds. We are talking about over 400 known subglacial lakes, a number that is constantly growing as our mapping technologies improve. And the crown jewel of this hidden world, the place that has captured the imagination of scientists and speculators alike, is Lake Vostok. It is an inland sea. At 250 kilometers long and 50 kilometers wide, it is one of the largest lakes on the planet by any measure. Its waters are estimated to be nearly a kilometer deep in places, and it has been sealed off from the surface world for at least 15 million years. It is a pristine, ancient, and perfectly isolated evolutionary experiment. For a long time, scientists thought of these lakes as isolated pockets, but more recent research has revealed something even more extraordinary. These lakes are not separate. Many of them are connected by a vast, continent-spanning network of subglacial rivers and streams. By analyzing subtle movements on the surface of the ice sheet, scientists have been able to map these hidden rivers, watching as they drain water from one lake and fill another. This discovery transforms our understanding of this world. It is not a collection of isolated ponds. It is a single, massive, and dynamic continental hydrology. It is a circulatory system. This means that if life evolved in one of the more geothermally active regions, it would have had a network of pathways to spread and colonize the entire hidden continent beneath the ice. This brings us to the final ingredient for life, the right chemistry. A world of pure, sterile water cannot support a food web. An ecosystem needs a constant supply of nutrients and chemical energy. In a subglacial lake, these would be provided by the same forces that keep the lake liquid. The geothermally heated water circulating through the rock at the bottom of the lake would be rich in dissolved minerals, iron, sulfur, manganese, silicates, and more. This is the chemical feedstock for life. At any geothermal vents on the lake floor, this process would be even more intense, creating powerful chemical gradients that are the perfect fuel for a chemosynthetic ecosystem, an exact parallel to the hydrothermal vent communities in our deep oceans. But what about oxygen? While simple anaerobic life can exist without it, the evolution of larger, more complex, animal-like life, as we know it, requires an oxidizer like oxygen to power a more efficient metabolism. In a sealed world, where would the oxygen come from? There are two primary sources. First, the ice sheet itself. The ice that forms the roof of these lakes is made of compressed snow that fell over hundreds of thousands of years. Trapped within that ancient snow are tiny bubbles of Earth's ancient atmosphere. As the ice at the base of the glacier slowly melts into the lake, it provides a slow but steady infusion of ancient, pre-industrial oxygen. Second, and perhaps more importantly, is the process of radiolysis. The bedrock beneath Antarctica, like all continental rock, contains natural radioactive elements. As these elements decay, the radiation they release can split the water molecules into hydrogen and oxygen. This provides a constant, in situ source of both a potential fuel, hydrogen, and a powerful oxidizer, oxygen. This means that the lakes are not just warm, wet, and filled with nutrients. They are chemically primed and ready to support a complex and potentially oxygen-breathing biosphere. The case for a living world is complete. The scientific case for a hidden, habitable world beneath the Antarctic ice is now compelling. We have a vast, continent-spanning network of liquid water lakes and rivers. We have a powerful, planetary engine in the form of geothermal heat, providing a constant source of energy. And we have a rich and complex chemistry, providing both the raw materials for life and the fuel for a non-solar food web. For decades, this was a beautiful and powerful theory, but in the early 21st century, it moved from the realm of theory into the realm of observed fact. The question was no longer, could life exist there? The question became, have we found it yet? The quest to answer that question is one of the most ambitious and challenging scientific endeavors in human history. To drill through miles of solid ice into a pristine, isolated ecosystem without contaminating it with our own surface microbes is a task of immense difficulty. It requires a level of sterilization and engineering that is more akin to building a probe for Mars than a terrestrial drilling operation. The drills themselves cannot be conventional. They must use sterilized hot water to melt their way down, and the entire system must be a closed loop to prevent any drilling fluid from escaping. After years of planning and logistical challenges, in January of 2013, a team of American scientists from the Wizard project achieved the impossible. They successfully drilled through 800 meters of ice to reach the surface of Lake Whillans, a smaller but still substantial subglacial lake. They carefully lowered a suite of sterilized instruments into the dark water below, and what they found was a confirmation of everything the theorists had hoped for. The water was not sterile, It was teeming with microbial life. Subsequent analysis revealed a density of over 100 microbial cells per milliliter, a population as dense as that found in our own deep oceans. This was not a sparse, barely surviving ecosystem. This was a thriving, active biosphere. And what were these microbes eating? By analyzing their genetics and the water's chemistry, the scientists discovered that they were chemoautotrophs. They were deriving their energy from the slow, patient oxidation of minerals like ammonium and iron that had been leached from the ancient rock and sediment at the bottom of the lake. The Wizard project provided the smoking gun. It was the first definitive proof of a functioning chemosynthetic ecosystem, a food web powered by rock, active and alive right now, deep beneath the Antarctic ice. This discovery, along with similar findings from the Russian team at Lake Vostok, transforms our hypothesis. The existence of a living world beneath the ice is no longer a matter of speculation. It is an observed, scientific fact. This brings us to the final, and perhaps most powerful, pillar of our scientific case, the argument from stability. Life on the surface of our planet, for all its beauty and diversity, is a story of constant, violent interruption. It is a game of evolutionary snakes and ladders. A species, or even an entire ecosystem, can spend 100 million years climbing the ladder of complexity, only to land on a square-marked asteroid impact or supervolcano and be sent right back to the beginning. The history of surface life is punctuated by at least 5 great mass extinction events, planetary-scale cataclysms that have repeatedly and violently pushed the reset button on evolution. At the end of the Ordovician period, a sudden ice age wiped out 85% of all marine species. In the late Devonian, another event, possibly related to ocean anoxia, again devastated life on a global scale. The Triassic-Jurassic extinction, likely caused by massive volcanic eruptions, eliminated most large amphibians and reptiles, paving the way for the dinosaurs. The Cretaceous-Paleogene extinction, triggered by an asteroid impact, famously ended the 150 million year reign of the dinosaurs in a geological instant, wiping out 75% of all species on Earth. But the most terrifying of all was the Permian-Triassic extinction event, known to paleontologists as the Great Dying. Triggered by a series of colossal volcanic eruptions in the Siberian traps that lasted for nearly 1 million years. This event pumped a catastrophic amount of carbon dioxide into the atmosphere. The result was runaway global warming, which in turn caused the oceans to become anoxic, devoid of oxygen, and highly acidic. Over 95% of all marine species and over 70% of all terrestrial species were extinguished. Life on Earth came terrifyingly close to being wiped out completely. The surface world, our home, is a cosmic shooting gallery, a place of constant, violent interruption and renewal. The subglacial world of Antarctica, by contrast, is a sanctuary. It is a planetary bomb shelter. A lake like Vostok, sealed beneath 4 kilometers of ice for 15 million years, is almost completely decoupled from the chaos of the surface. An asteroid impact is nothing more than a faint, distant tremor. An ice age, for a world already defined by ice, is irrelevant. A supervolcano poisoning the atmosphere has no effect on a world with its own sealed atmosphere. While life on the surface was being repeatedly burned, frozen, and poisoned, the deep world beneath the ice would have remained a realm of profound geological scale stability. This means that a subglacial lineage would be an unbroken chain of life. While surface evolution was being constantly reset, subterranean evolution could have been a slow, patient, and continuous climb towards complexity. This provides the single most important ingredient for the evolution of high intelligence: time. The entire 15 million year history of the subglacial ecosystem of Lake Vostok has been one of near perfect stability. To put that in perspective, in the last 15 million years on the surface, the continents have drifted into their modern positions, the ice ages have come and gone, and our own ancestors have evolved from early, ape-like primates into a species that can build cities and dream of the stars. What might 15 million years of uninterrupted evolution in a completely alien environment be capable of producing? This immense, unbroken timescale makes the idea of an ancient, complex, and potentially intelligent civilization not just plausible, but in some ways, almost logical. This leads us to the final question of this scientific inquiry. We have established a confirmed living biosphere in a vast, ancient, and perfectly stable incubator. We have a world with all the necessary ingredients for life, and a world with the gift of uninterrupted time. But for intelligence to arise, there must be evolutionary pressures that favor it. What challenges in this dark, cold, and stable world would make a big brain a more effective survival tool than a bigger claw or a thicker shell? The challenges are unique and profound. The problem of perception in total darkness would drive the evolution of sophisticated active senses, like echolocation. The problem of navigating a three-dimensional, aquatic world with no landmarks would require immense computational power. The problem of survival would be a silent arms race of sensory acuity versus stealth. And the unique challenge of living under a constantly moving, grinding, 4-kilometer thick ceiling of ice would strongly favor a species that could understand, and perhaps even predict, the slow, terrifying geology of its own sky. The scientific case is now complete. We have a confirmed, living biosphere in a vast, ancient, and perfectly stable incubator with all the necessary ingredients for life and a powerful set of unique evolutionary pressures that would favor the evolution of intelligence. The foundation is laid, and so we can now ask, what did 15 million years of uninterrupted evolution in this hidden world actually produce? What are the children of the ice really like? The scientific case is now complete. We have a confirmed, living biosphere in a vast, ancient, and perfectly stable incubator with all the necessary ingredients for life and a powerful set of unique evolutionary pressures that would favor the evolution of intelligence. The foundation is laid. And so, we can now ask, what did 15 million years of uninterrupted evolution in this hidden world actually produce? What are the children of the ice really like? To begin this journey of speculative biology, we must understand that any life which evolved beyond the microbial in a subglacial lake like Vostok would have been forged by three fundamental and inescapable environmental forces: the eternal absolute darkness, the immense bone-crushing pressure, and a low-energy food web powered not by the sun, but by the faint chemical whispers of the Earth's core. These three forces would shape their bodies, their senses, and their very minds into forms that would be profoundly alien to us. Let us first consider the pressure. Life on the surface of the Earth exists under the gentle weight of one atmosphere. Life in Lake Vostok exists under a pressure of nearly 400 atmospheres. This is a force of 400 kilograms pressing down on every square centimeter of a creature's body. But it is not just the pressure of the water, It is the nature of that pressure, applied by a 4-kilometer thick, continent-sized ceiling of solid ice. This is a physical reality so extreme that it rewrites the rules of biology. At such pressures, the basic chemistry of life begins to fail. The delicate, three-dimensional proteins that act as the enzymes for all metabolic processes are squeezed and deformed, their shapes distorted until they can no longer function. The lipid membranes that form the walls of our cells become waxy and rigid, preventing the flow of nutrients and waste. Gases like oxygen and nitrogen become toxic at high concentrations in the blood. For complex, multicellular life to exist here, it must be rebuilt from the ground up at a molecular level. The inhabitants of this world would be the ultimate piezophiles, or pressure lovers. Their cells would be filled with special organic molecules called piezolites, which would act like internal scaffolding, protecting their proteins and enzymes from being crushed and allowing them to function. Their cell membranes would be made of unique, unsaturated fats that remain pliable and fluid even under immense pressure, and they would likely have no internal, gas-filled spaces at all. Swim bladders, lungs as we know them, and other voids would be a physical impossibility, a fatal liability. Their bodies would be solid, dense, and perfectly adapted to the crushing embrace of their world. Their anatomy would reflect this. Skeletons would not be needed to fight gravity, but to provide leverage for powerful muscles moving through dense, cold water. These skeletons would likely not be made of brittle, calcium-based bone, but perhaps of a more flexible, pressure-resistant cartilage, or even of biologically precipitated silica. They would be slow-moving creatures, built for power and endurance, not for speed. This leads to the second great shaping force, the low-energy food web. The chemosynthetic ecosystem of a subglacial lake, while stable, would be profoundly energy-poor compared to the sun-drenched surface world. The amount of available calories would be a tiny fraction of what is available in a forest or a shallow sea. This scarcity would be the single greatest driver of their evolution, forcing every aspect of their biology towards a single, overriding principle: absolute efficiency. Their metabolisms would be incredibly slow. They would be cold-blooded, their internal body temperature matching the near-freezing water around them. Every movement would be slow, deliberate, and calculated to conserve every last joule of energy. They would likely be ambush predators, waiting patiently in the dark for weeks or months for a single meal, or methodical, slow-moving grazers, scraping the bacterial mats from the lake floor. The frantic, high-energy lifestyles of surface creatures would be an impossibility, and this slow metabolism, combined with the extreme stability of their environment, would have a profound effect on their lifespans. On the surface, life is often short and brutal. The high risk of predation, disease, and environmental change creates an evolutionary pressure to reproduce quickly. In the stable, predictable, and largely threat-free world of a sealed subglacial lake, this pressure is removed. With slow metabolisms and few external threats, the inhabitants could have lifespans that would seem mythological to us. Their lives would not be measured in years or decades, but in centuries, or even millennia. They would be ancient, slow, patient, and thoughtful beings. Their lives lived at a geological pace that mirrors the slow, grinding movement of the ice sheet above them. From this unique biology, a unique sensorium would arise. The third great force, the eternal darkness, would mean that sight is a useless extravagance. Any creature that wasted precious metabolic energy on developing or maintaining eyes would be at a severe evolutionary disadvantage. Their brains would not have visual cortices. Their entire perception of reality, their consciousness, would be built from a symphony of other senses, senses that are secondary to us, but would be primary to them. Their primary, world-building sense would be chemoreception. In the cold, still, and contained waters of a sealed lake, the senses of taste and smell would merge into a single, incredibly powerful tool for perceiving the world at a distance. The geothermal vents on the lake floor would be the oases of life, and they would constantly release plumes of chemical-rich water. The lake dwellers would be able to taste these faint chemical trails from miles away, following them through the dark water back to the sources of life. Their entire world would be a landscape of flavors. They could taste the unique mineral signature of a specific vent. They could taste the faint metabolic byproducts of a potential prey animal, or the fear pheromones of a startled one. This powerful chemical sense would be supplemented by an exquisitely sensitive sense of mechanoreception. In a world of total darkness, the water itself becomes the primary medium for information. The entire surface of a lake dweller's body would likely have evolved to become a complex and sensitive organ, a living hydrophone capable of detecting the faintest pressure waves and vibrations. This would be their close-range vision. They could feel the subtle push of water from a swimming creature meters away, building a three-dimensional picture of its location and movement from these pressure ripples alone. They could feel the eddy currents swirling around a piece of rock, allowing them to map their immediate surroundings by touch without any physical contact. They could feel the gentle, constant currents created by the geothermal vents, using them to navigate their world like a bird using the wind. And for active, long-range perception, for mapping the vast and featureless expanses of their lake, and for hunting, they would have inevitably evolved a sophisticated form of echolocation. But their sonar would be profoundly different from that of a dolphin or a bat. A dolphin uses sonar in a vast, open ocean. The lake dwellers would be using it in a contained and acoustically complex environment. Their sound waves would echo not just off their target, but off the rocky floor below and, most importantly, off the colossal, sound-reflecting ceiling of solid ice above. Their brains would need to be masterful acoustic computers capable of filtering out this cacophony of echoes to isolate the single, faint signal of a potential meal or a distant cavern wall. They would need to build a high-resolution, constantly refreshing mental model of their world from a storm of complex, overlapping sound waves. This immense computational challenge would be a powerful driver for the evolution of a large and complex brain. It is also plausible that they would have evolved a true sixth sense that is common in aquatic life on Earth: electroreception. Many sharks and fish have the ability to detect the faint bioelectric fields generated by the nervous systems and muscle contractions of all living things. In the absolute darkness of a subglacial lake, this would be a life sense. A creature hiding, perfectly still and silent in a crevice, could not hide its own vital spark. The lake dwellers could use this sense to find prey buried in the sediment on the lake floor, or to navigate by the faint, permanent electromagnetic anomalies in the bedrock. And finally, they would have a sense that is unique to their world. They would live under a sky that is not empty, but is a 4-kilometer thick, moving, grinding, and groaning sheet of solid ice. They would be natural glaciologists. Their entire bodies would be sensitive to the slow, powerful, low-frequency vibrations of the ice sheet above them. They would be able to feel the weather of their sky, the subtle shifts in pressure that signal a change in the glacier's flow, the distant tremor of a crevasse opening miles above them, the slow, grinding sound of the continent itself moving overhead. This constant, overwhelming presence of the ice would be the single greatest feature of their sensory reality. Let us now try to imagine what reality would feel like for such a being. It would not be a world of objects and images. It would be a constantly shifting three-dimensional tapestry of sensory inputs, a faint, alluring taste of iron and sulfur on the current from the east, signaling a distant vent, a warm bloom of water from below, a sign of geothermal activity, the rhythmic pressure wave of a fellow being approaching from the right, the constant, updating sonar image of the immediate surroundings, painted in acoustic textures, and all of this would be set against the constant, deep, resonant hum of the living ice sheet above them. It would be a world of profound, immersive, and total awareness. Without the focused, directional nature of sight, their consciousness might be far more holistic and less individualistic than our own. Their sense of self might be a diffuse, ambient awareness, deeply intertwined with the chemical, physical, and acoustic state of the lake around them. We have now imagined the being, the child of the ice, a slow, ancient, and immensely long-lived creature, a being forged by pressure, adapted to a low-energy world of darkness and cold, a mind that perceives its reality not through light, but through a symphony of feeling, taste, and sound. We have established the biological plausibility of such a creature. The next question is, what would such a being create? How would a civilization of ancient, slow, and communal beings who feel the world rather than see it build their society and their technology in the eternal, silent darkness of the Vostok Sea? We have now imagined the being, the child of the ice. We have explored its body and its mind, a creature forged by pressure, darkness, and deep time. The next question is, what would such a being create? How would a civilization of ancient, slow, and communal beings who feel the world rather than see it build their society and their technology in the eternal, silent darkness of the Vostok Sea? Their creations, like their bodies, would be a direct reflection of their unique environment, with no fire, no metal, no wood, and no concept of building against gravity. Their entire technological path would be alien to our own. Their engineering would not be a mastery of physics and dead matter, but a deep, symbiotic partnership with the two forces that define their world, biology and geology. Their first and most versatile pillar of technology would be bioengineering, the art of flesh shaping. Their workshops would not be forges, but silent, glowing, and meticulously maintained genetic nurseries. Their great engineers would be geneticists, and their primary tool would be a technology capable of editing and programming the code of life itself. Their tools would not be manufactured objects, but living, purpose-bred organisms. A cutting tool would not be a steel blade, but a cultivated creature with a naturally sharp biosilica edge. A gripping tool would be a symbiotic organism with powerful, controllable tentacles. A light source would be a living culture of bioluminescent bacteria, bred for a specific color and intensity. Their relationship with their technology would be that of a farmer to their livestock, a gardener to their plants. It would be a world of constant care, of nurturing, and of understanding the life cycles of their own creations. This mastery of biology would be most critical in the engineering of their life support systems. Their lake, while vast, would be a closed and fragile ecosystem. The survival of their civilization would depend on their ability to maintain it in a state of perfect, unchanging equilibrium. We can imagine them creating vast, free-floating, coral-like organisms, the living machines that would serve as the lungs and kidneys of their world. These colossal, slow-moving biofilters, perhaps kilometers in diameter, would drift through the lake, their entire purpose being to purify the water, absorb the metabolic waste products of the civilization, and maintain the delicate chemical and thermal balance of the entire ecosystem. These would be their greatest and most important creations, living, self-repairing, continent-sized pieces of biotechnology. Their architecture, their very cities, would be an extension of this biological mastery. Their foundation, their ground, would be the bedrock at the bottom of the lake, particularly around the life-giving geothermal vents. Here, they would use their biological tools, perhaps colonies of acid-secreting, rock-boring microbes, to carve their most sacred and ancient structures directly into the stone. These would be their temples, their great halls, their archives, a city carved, not built, but the majority of their living space would be in the open, three-dimensional space of the water. Here, their buildings would be living things. They would not construct a house, they would grow one. Imagine them cultivating a single, massive, anemone-like polyp. Over centuries, they would guide its growth with carefully managed nutrient flows and genetic instructions, shaping its structure to form a great, hollow, multi-chambered dwelling. The walls of this building would be living, self-repairing tissue. The tendrils on its outer surface could be engineered to harvest nutrients from the surrounding water, and its internal chambers would glow with a soft, genetically programmed bioluminescence, the living wallpaper of their homes. An entire city would be a vast, interconnected reef of these living, grown structures, a floating forest of organic architecture. Each dwelling would be connected to its neighbors by flexible, living, and tube-like corridors, creating a single, vast, and contiguous superorganism. The entire city would be anchored to the geothermal vents on the lake floor by long, incredibly strong, and living tethers, swaying gently in the slow, ponderous currents of the deep. It would be a silent, glowing, and organic metropolis in the eternal dark. The energy that powered this entire civilization would be the geothermal heart of their world. Their power plants would be sophisticated biological structures built directly over the most active hydrothermal vents, designed to manage the flow of heat and chemical energy and distribute it throughout the city reef via a network of living conduits. But the most important organizing principle of their entire society would be the law of perfect recycling. In a sealed lake, isolated for 15 million years, there is no such thing as waste. Every dead organism, every shed molecule, every byproduct of metabolism would be a precious resource to be captured and reintegrated into the system. Specialized, engineered organisms, their recycling machines, would be the foundation of their society, consuming all detritus and breaking it down into its constituent elements to be fed back into their fungal gardens and aquaculture systems. They would be a civilization with a zero-waste economy, not as a matter of ecological virtue, but as a fundamental law of survival. Scarcity and the absolute necessity of perfect recycling would be the central principle that would shape their economy, their technology, and their very philosophy. This unique environment and technology would inevitably lead to a unique form of society. In a world of sensory transparency, where the chemical and physical state of your neighbors is a constant, ambient perception, and in a fragile, perfectly balanced, engineered world where a single individual's mistake could lead to a cascading ecosystem collapse. The concept of radical individualism would be a dangerous and alien idea. Their society would be profoundly collectivist. The survival, health, and harmony of the city reef would be the highest possible virtue. The basic unit of their society might not be the individual, but the communal dwelling or the entire city itself. Their consciousness might be a form of we before it is an I. This could manifest as a social structure that is more akin to that of a beehive or an ant colony, a form of eusociality where individuals are born into or assume specific roles for the good of the whole. There would be the engineers who designed and tended to the geothermal power stations. There would be the geneticists, the masters of their flesh-shaping technology. There would be the farmers who managed the chemosynthetic food webs, and there would be the thinkers or the historians, beings whose long lives would be dedicated to preserving the memory and the knowledge of their people. It would be a society of perfect order and harmony, a social machine as complex and as balanced as the engineered ecosystem it inhabited. From this collective, symbiotic, and profoundly balanced society, a unique culture would emerge. Their art, their philosophy, and their search for meaning would be a direct reflection of their strange and isolated world. What is beauty to a being that has never seen light? What is music to a creature that feels the world through vibration? What is God to a civilization whose entire universe is a dark, warm lake trapped between a fiery core and a sky of crushing, moving ice? Their highest art forms would be an expression of their unique, non-visual sensorium. An artist in this world would not be a painter or a sculptor in our sense of the word. They would be a master of chemistry, of pressure, and of living light. Their greatest works would not be objects to be looked at, but environments to be experienced. Imagine a great, silent concert hall, a resonant chamber carved from the bedrock. The artist, their composer, would not create a symphony of sound, but a symphony of sense. They would release a carefully sequenced and incredibly complex series of pheromonal molecules into the chamber, a scent symphony that would tell an epic story with different molecules representing characters, emotions, and events. It would be an art form that is inhaled, tasted, and felt directly by the nervous system, a story told in the language of pure emotion and memory. Their sculpture would be kinetic, an art of pressure and flow. An artist might use their own body, or a series of living, cultivated tools to create a silent, tactile ballet of complex, moving patterns of pressure waves in the water. This would be a form of art that could be seen and appreciated from a great distance. A silent story told in the language of pure motion, felt on the skin as a series of complex, meaningful vibrations. And their painting, as we have discussed, would be the slow, hypnotic, and vast ballets of their cultivated bioluminescence, the great, silent, shifting murals of living light that would tell the long, slow story of their history over the course of millennia. But perhaps their highest art form of all would be ecological engineering itself, the design and creation of a new, perfectly balanced and beautiful city reef, a new self-sustaining ecosystem, would be their equivalent of composing a grand symphony or building a great cathedral. It would be an act of ultimate creation, a testament to their perfect harmony with the world they had forged for themselves. And what of their philosophy, their search for meaning in the cosmos? A civilization with no knowledge of a sun, a moon, or a star would have a profoundly different cosmology. Their entire universe would be their lake. Their search for meaning would be an inward-looking journey, not an outward-looking one. They would have no astronomy, no concept of other worlds, no pantheon of sky-dwelling deities. Their gods would be the great, tangible, and active forces of their world, a holy trinity of their environment. At the base of their cosmology would be the core, the hot, rocky floor of their world. This would be their creator deity, the hearth father, the life-giving source of all warmth, all energy, and all the chemical nutrients that fueled their existence. It would be a god of creation, of power, and of nourishment. The second part of their trinity would be the water, the lake itself. This would be the Great Mother, the nurturing, all-encompassing medium that connected all things. It was the medium of their life, their senses, their communication. They would not see themselves as separate from the water, but as a temporary expression of it. And the third, and most powerful and terrifying, deity would be the ice, the 4-kilometer thick, continent-sized sheet of solid ice that formed their sky. The ice would be a complex and dualistic god. It would be the great protector, the shield that kept their warm, stable world safe from the abstract, terrifying concept of an outer void, a place of absolute cold and non-existence. But it would also be the great oppressor. They would feel its colossal, crushing weight in every moment of their lives. And through their seismic sense, they would hear its voice, a constant, deep, and terrifying groan, the sound of a continent of ice grinding and shifting overhead. Their entire philosophy would be a meditation on the balance between these three forces, the life-giving heat from below, the nurturing medium around them, and the crushing, cold weight from above. Their concept of time would be geological, with no day or night and no seasons, the frantic, short-term thinking that defines so much of human culture would be absent. They would plan projects that take millennia to complete. Their own long lives would reinforce this patient, deliberate worldview. This would shape their view of life and death. The individual life would be a fleeting, temporary thing, a brief vibration in the eternal water. But the collective, the city reef, the species would be seen as effectively immortal, as permanent as the lake itself. Their goal would not be the salvation of the individual soul, but the continuation of the great, communal consciousness, the preservation of the perfect equilibrium of their world. We have now built a complete, detailed, and plausible vision of the civilization that could be thriving in the darkness beneath the Antarctic ice. It is a world complete in itself, a culture of profound isolation, a communal, superorganism-like society of ancient, slow-moving beings living in living, glowing cities, a people who perceive their reality through a symphony of non-visual senses, and whose entire culture is a deep and complex reflection of the geothermal and glacial forces that govern their world. Now that we have imagined this civilization, we must return to our own world, to our own science, and ask the final, most difficult question: how would we find them? What faint, ghostly traces of their existence might be detectable, frozen in the ice above or buried in the rock below? We have now built a complete, detailed, and plausible vision of the civilization that could be thriving in the darkness beneath the Antarctic ice. It is a world complete in itself, a culture of profound isolation. But we must now return to our own world, to our own science, and ask the final, most difficult question: how would we find them? What faint, ghostly traces of their existence might be detectable, frozen in the ice above or buried in the rock below? Our journey now shifts from speculative biology and philosophy to a new and challenging field, subglacial archaeology. We must become detectives, searching for the evidence of a lost world at the bottom of our own. The first and most overwhelming challenge of this search is the barrier itself. Human archaeology is a science of the surface. We dig through a few meters of soil and sand to uncover the ruins of our past. But the world of the children of the ice is buried beneath a moving, grinding, continent-sized glacier that is, in places, nearly 3 miles thick. We cannot simply dig a hole. This is a challenge of a completely different order of magnitude. The ice sheet is not just a passive obstacle, it is an active geological force. As the glacier flows, it scours and grinds the bedrock beneath it, a colossal eraser that could destroy any shallow evidence. But it is also a perfect vault. The ancient, deep ice at its base is a time capsule, and the dark, cold water beneath it is a realm of perfect preservation. The evidence, if it exists, is both protected and hidden by the most formidable barrier on the planet. Faced with this barrier, where do we begin our search? Our first and most powerful tool is not a shovel, but a drill. The science of ice core drilling has been one of the most important fields for understanding our own planet's past. By drilling deep into the ice sheets of Antarctica and Greenland and extracting long, continuous cylinders of ice, we can read the history of our atmosphere and climate, layer by frozen layer, going back nearly 1 million years. These ice cores contain trapped bubbles of ancient air, layers of volcanic ash, and dust from distant continents. They are our planet's memory. For our investigation, the most important part of an ice core is the part we rarely reach: the basal ice, the last few meters at the very bottom, right at the interface with the hidden world below. Let us think of the ice sheet as the sky of the subglacial world. Any process that happened in their hidden lake, any gas they produced, any life that died and floated upwards, could have become trapped and frozen into this ceiling of ice. The basal ice is their fossil record. By analyzing these deepest, oldest layers, we could search for 2 types of chemical anomalies. The first would be the signature of their industry, their technology. We imagined a civilization whose life support, architecture, and tools were all based on a complex and active biotechnology. Any industrial-scale biological process, even a perfectly efficient one, would have trace byproducts. They might have produced unique, stable waste gases that we would not expect to find in nature. If these gases dissolved into their lake water and were then frozen into the basal ice, an ice core could reveal a sudden, anomalous spike in specific chemicals that have no known natural source. It would be the equivalent of our own civilization's spike in carbon dioxide and chlorofluorocarbons, a clear and undeniable technosignature written in the ice. The second, and even more profound, clue would be the signature of their biology itself. The water of the lake, containing their microscopic life, would have been constantly freezing onto the bottom of the ice sheet. By analyzing the DNA and the molecular fossils or biomarkers from this basal ice, we could uncover an entire shadow biosphere. We could find the genetic and molecular fingerprints of a whole ecosystem of life that is completely unrelated to anything on the surface of the planet. Finding a suite of complex lipids, sterols, and DNA sequences that do not match any known bacteria, archaea, or eukaryote on the entire tree of life would be the ultimate proof. It would be the genetic fingerprint of their world, a testament to 15 million years of separate, independent evolution. We would not need to find one of the inhabitants. We would have found their shadow frozen in their sky. Our second great tool for this investigation is geophysics. If the ice core is our microscope, then seismic surveys are our telescope for peering through the ice. By sending powerful sound waves or radar signals down through the ice sheet and listening to the echoes that bounce back from the bedrock, we can create a three-dimensional map of the hidden continent. Our current maps of the subglacial world are still relatively low resolution, capable of showing us vast mountain ranges and the outlines of the largest lakes. But as this technology becomes more powerful and more precise, we could begin to search for the specific signatures of intelligent construction. Nature, for all its complexity, is rarely a precise architect. Its forms are fractal, chaotic, and governed by the simple laws of erosion and deposition. Intelligence, however, can impose abstract, mathematical forms onto the world. A civilization's ruins would be a geometric anomaly. With future, high-resolution seismic surveys of the floor of Lake Vostok, we could search for these anomalies. We would look for patterns that defy natural geology, unnaturally smooth, vast, and flat plains that could be the sign of ancient agriculture. We would look for repeating, geometric patterns that could be the grid-like layout of a city. We would look for the perfect, repeating curves of carved, domed structures, or the unnatural, reef-like forms of their grown architecture. Of course, any single discovery would be ambiguous. A straight line could be a natural fault line. A circular structure could be an ancient, subglacial impact crater. But the proof would lie in finding a pattern of improbability. A single perfect square on the lake floor is a curiosity. 1,000 perfect squares, arranged in a grid over 100 square kilometers, is a civilization. The evidence would be statistical, a conclusion drawn from a landscape that is simply too ordered, too geometric, and too complex to have been formed by chance. It would be the shadow of their city, mapped in the echoes, bouncing back from the bottom of the world. Beyond the direct evidence that could be found in the ice, we must also consider the more subtle, indirect clues that a massive, subterranean civilization would leave behind. We must learn to read the faint whispers of the planet's fundamental forces. Our third great tool in this investigation, after the drill and the seismograph, is the gravimeter. The Earth's gravitational field, which feels so constant to us, is in fact not uniform. It varies slightly from place to place, depending on the density of the rock mass beneath. A dense, metallic ore deposit will create a slightly stronger gravitational pull, while a less dense salt dome or a hollow cavern will create a slightly weaker one. By using incredibly sensitive instruments on the surface and in satellites like NASA's GRACE mission, we can map these minute variations, creating a gravity anomaly map that gives us another way to see the hidden structures of the crust. A massive, hollowed-out subterranean city or a vast network of tunnels would represent a significant mass deficit. It would be a region of the crust that is less dense than the surrounding solid rock. In theory, this could produce a negative gravity anomaly, a signature that we could detect from the surface or even from orbit, and it is here that we find our most tantalizing, real-world clue. Beneath the vast, featureless ice of a region called Wilkes Land in East Antarctica lies one of the largest gravity anomalies on the entire planet. It is a massive, circular feature, over 300 miles in diameter, a place where the gravity is mysteriously weaker than it should be. The prevailing scientific hypothesis is that this is the scar of a colossal impact event, the site of a crater more than twice the size of the Chicxulub crater that killed the dinosaurs. This impact, which may have occurred 250 million years ago, could have even been a trigger for the Permian-Triassic extinction event, the Great Dying. This is a powerful and well-supported theory. But for the purpose of our thought experiment, the Wilkes Land anomaly serves as a perfect example of the type of clue we would be looking for. We are not claiming that this anomaly is a hidden city, but we are pointing out that a massive subterranean complex, a civilization that had hollowed out a continent-sized section of the crust, could produce exactly this kind of gravitational signature. A similar case could be made for magnetic anomalies. By mapping the Earth's magnetic field with magnetometers, we can detect variations caused by the composition of the rock below. A technologically active civilization, even one without electricity as we know it, would almost certainly leave a magnetic trace. Their use of geothermal energy, the movement of vast quantities of geothermally heated water rich in iron, or their potential processing and concentration of magnetic minerals could create a complex and unnatural magnetic signature, another fingerprint on the planet that could be detected from the surface. This entire investigation, however, has been framed from a single, arrogant perspective, our own. We have spent this whole time asking how we could find them. But what if we have the question entirely backwards? What if they have already found us? Let us return to the nature of their senses. We imagined a civilization that perceived its world primarily through the sense of vibration, a people who had learned to read the subtle, seismic heartbeat of their planet. For such a civilization, the surface world of the 20th and 21st centuries would be an incomprehensibly loud and violent place. Our civilization is seismically deafening. Our largest mining operations, our fracking for natural gas, and even the constant, low-level hum of our great cities create a seismic noise that travels through the entire crust of the planet. But most dramatically, there are our nuclear weapons. The era of atmospheric and underground nuclear testing in the mid-20th century sent colossal, brutal, and completely unnatural shockwaves reverberating through the entire planet. For a civilization whose primary sense was a hypersensitive form of seismology, a single underground nuclear test would not just be a distant tremor, it would be a planetary-scale scream. It would be a violent, agonizing, and terrifying wave of pure chaos. They would have heard the dawn of our atomic age as a series of brutal, deafening explosions. They would hear our modern industrial activity as a constant, chaotic, and irritating noise. What would they think of us, the noisy, chaotic, and terrifyingly violent children living on their ceiling? Would they see us as a threat, a curiosity, or a chaotic, short-lived infection on the skin of their world, a problem that will eventually, like a surface storm, simply burn itself out? We have now laid out the daunting task of the subglacial archaeologist. The search would be a multifaceted investigation for a pattern of anomalies. There would be no single smoking gun. The proof of their existence would be in the convergence of the evidence, a layer of ice with anomalous chemistry and shadow biosphere DNA, directly above a region of the lake floor with improbable, geometric structures that also corresponds to a significant and unexplained gravitational and magnetic anomaly. Individually, each of these findings is a curiosity. Together, they are a manifesto. They would be the faint, ghostly, but undeniable echo of a lost world. This investigation leads us to a final, and even more profound, set of questions. If they are there, what is their fate? And what is our responsibility to this silent, hidden neighbor? This is the final and most important part of our journey. We have now laid out the daunting task of the subglacial archaeologist. We have learned what to look for. the improbable geometries, the chemical ghosts, and the tantalizing clues from our one real-world deep Earth experiment. But this entire investigation, this entire chain of speculation, leads us to a final and even more profound set of questions. If a civilization is, or was, down there, what is their fate? And what is our responsibility to this silent, hidden neighbor? This is the final and most important part of our journey. Let us first consider the possibility that we are searching only for ghosts. If the children of the ice are extinct, what could have possibly destroyed a civilization that was protected from every cataclysm that has ever struck the surface of the earth? The answer would be a profound cautionary tale. Perhaps their end came from within. Their perfectly balanced, bioengineered ecosystem, their greatest triumph, could have also been their greatest vulnerability. A single, engineered microbe, designed to recycle waste, could have mutated beyond their control. A biological plague that consumed their entire fungal food supply and brought about a swift and silent famine. In a world of limited genetic diversity, a single pathogen could have been an apocalypse. Or perhaps their mastery of geothermal energy was their undoing, a technological miscalculation that triggered a catastrophic chain reaction, turning their warm, life-giving vents into a source of planetary destruction. It is a sobering thought that the same intelligence that allows a civilization to create a paradise may also provide the tools to turn it into a tomb. Alternatively, their end could have come from a force of nature even they could not withstand. While they were safe from the chaos of the surface, they were not safe from the long, slow life cycle of the planet itself. The Earth's core, their distant fiery sun, is not eternal. Over geological time, the geothermal output of the planet wanes. The geothermal vents that were the very foundation of their existence would have become less frequent, less powerful, and would have eventually, one by one, gone cold. Theirs would have been a slow, tragic extinction, a civilization clinging to the last embers of a dying planetary fire, a story not of a sudden cataclysm, but of a long, final winter. Or perhaps the sky itself fell, a massive shift in the ice sheet above, a catastrophic fracturing event, could have breached their lake, flash freezing their entire world in an instant. And then there are the stranger, more unsettling possibilities. What if they did not die at all? What if they are still there? As we have established, our industrial and nuclear activity for the past century has sent a series of violent, screaming shockwaves through the planet's crust. For a civilization whose primary sense is a hypersensitive form of seismology, our presence would be an undeniable and terrifying fact. What would they think of the noisy, chaotic, and unbelievably reckless creatures living on their ceiling? It is entirely plausible that they would have made a conscious and very wise decision to remain perfectly, absolutely silent, to hide. Their silence, in this case, would not be an absence. It would be a choice. In the end, we have no evidence, and we may never have an answer. But the purpose of this thought experiment, the journey to the world beneath the ice, was never truly about finding a lost civilization. It was about holding up a mirror to our own. This is the purpose of the PsyBox, to open a container of ideas that forces us to look at ourselves in a new light. The story of the children of the ice is one such mirror, and in its dark, silent surface, it shows us ourselves in three unsettling reflections. First, it reflects our profound biases. The entire thought experiment forces us to confront the fact that our way of being, our reliance on sight, our mastery of fire, our technologies of metal and combustion, is not a universal template for intelligence. It is a local, contingent path, the result of the specific environment in which we evolved. The children of the ice show us that another path was possible, and that our assumptions about what to look for in the universe may be profoundly, cripplingly wrong. Second, their hypothetical story reflects our own breathtaking fragility. We, humanity, have had a civilization capable of recording its own history for perhaps 6,000 years. The civilization of Lake Vostok could have existed in a state of perfect stability for 15 million years, and yet even they could be gone. Their utter disappearance, after an existence that was thousands of times longer than our own, is a mirror for our own legacy. It is a profound lesson in cosmic humility, forcing us to ask, in a million years, what will be left of our great cities, our art, our science? Will there be even a single, anomalous molecule to prove that we were ever here? And finally, and most importantly, their story is a mirror that reflects not just our ignorance, but our responsibility. We are, at this very moment, in a race to be the first to drill into the pristine, isolated world of Lake Vostok. The scientific prize is immeasurable. The chance to discover a completely new biosphere, a second genesis of life on our own planet. It could be the single greatest biological discovery in human history. But this quest carries with it a terrifying and profound ethical weight. We are not just explorers, we are potential contaminators. Our own bodies, our drills, our equipment are all teeming with the hardy, aggressive, and competitive microbes of the surface world, an ecosystem that has evolved in perfect isolation for 15 million years would have no defenses against them. A single microbe from our world, introduced into theirs, could be an apocalyptic plague, a biological firestorm that could wipe out their entire, unique biosphere before we even had a chance to understand it. The paradox is that the very act of discovery could be an act of total annihilation. This is the ultimate question that the hypothesis forces us to confront. We are not just explorers in an empty wilderness. We might be a loud, clumsy, and potentially lethal neighbor, about to break down the door of a silent recluse who has been living in peace for millions of years. Do we have the right? Is our scientific curiosity worth the potential risk of committing a form of planetary-scale genocide? The great lesson of the world beneath the ice is that with great knowledge comes great responsibility. It is a call not just for inward exploration of our own planet, but for thoughtful, careful, and humble exploration. The answers to our deepest questions may indeed be waiting for us in the dark waters of Lake Vostok. But perhaps the first sign of our own intelligence would be to pause, to consider the consequences, and to decide if we are truly ready for what we might find and what we might destroy. And that brings our video to a close. Thanks for joining us on PsyBox.